Hello बच्चों, let's read this question. At some place in universe, an atom consists of a positron revolving around an antiproton. The ratio of wavelength of the corresponding spectral lines from this atom and ordinary hydrogen atoms is. So students, इस क्वेश्चन में हमें बोला गया that किसी यूनिवर्स में एक एटम होता है such that it contains positron revolving around antiproton. अब स्टूडेंट्स हमें बताना है व्हाट इज द रेशियो ऑफ वेवलेंथ ऑफ corresponding spectral series in this atom, that is lambda in this atom upon lambda of hydrogen atom. For that, please note the key concept of this question. Concept of this question, which says total energy of a system is given by TE equals to the sum of kinetic energy plus potential energy. Now students, when this was revolving around this antiproton, this has some velocity, and due to this velocity it has some kinetic energy whose value can be given as half mv square. Moreover, the value of potential energy we can write this positron is experiencing some force of attraction, and it is at distance r. So for that we can write the potential energy as k q1 q2 upon r, where q1 represents charge on positron and q2 represents charge on antiproton. Let's say this is an atom of atomic number z. So charge on positron we can write as E. This is because charge on positron is same as charge on electron, and Q2 represents charge on antiproton. Let's say this is an atom of atomic number Z. So it will have number of antiproton as Z, and antiprotons has charge same as proton. So the number of charges will be Z E upon R. So from here we can write KZE square upon R. Now kinetic energy equals to half m v square. From Bohr's postulate, we can say angular momentum of nth orbit is given by n into h upon 2 pi, and this was the positron which was revolving around antiproton. So this the centripetal force required by this positron to move in circular motion, this is provided by force of attraction on this positron due to this antiproton. So F centripetal is equal to force of attraction, which is given by k q1 q2 upon r square, where r is this radius of positron's orbit. Now F centripetal's value we can write mv square upon r, k q1 q2 upon r square. This will cancel out one of the r. So mv square, this is given as k q1 into q2, where q1 is e and q2 is ze. So mv square equals to k into z e square. Students, kinetic energy की expression थी half mv square. So on multiplying with half we will get kinetic energy. यहाँ से हमें total energy की value मिली kinetic energy plus potential energy. जहाँ से kinetic energy हमने ये निकाला, this implies kinetic energy equals to half k z e square. So this is half k z e square, and potential energy की value k z e square. यहाँ पर थी पोटेंशियल एनर्जी की वैल्यू माइनस के जेड ई स्क्वायर अपॉन आर. So we will left with minus k z e square upon r. So this is the total energy. But students, we have to calculate r so that we can find the total energy expression in the nth orbit of an electron. So from here we can write mvr equals to nh upon 2 pi. So v equals to nh upon 2 pi m into r, and the value of v we can substitute here. in this expression mv square equals to kz e square. This is upon r. So mv square equals to kz e square upon r. So m into v and h upon 2 pi mr square equals to k z e square upon r. So m into n square h square upon 4 pi square m square r square. This is equal to k z e square upon r. So स्टूडेंट्स यहाँ से इस r से एक r square की वैल्यू कैंसिल. So and this m will cancel out one of the m. So n square h square upon 4 pi square mr. This must be equal to k z e square. आपको न्यूमरेटर में लेकर जाएंगे to find the value of r equals to n square h square upon 4 pi square m into k z e square. That is r equals to h square upon 4 pi square m into k z e square into n square की वैल्यू सब्स्टिट्यूट कर सकते हैं इस प्लेस पे, टोटल एनर्जी के प्लेस पे. सो टोटल एनर्जी इक्वल्स टू माइनस के जेड ई स्क्वायर अपॉन आर. आर की जगह एन इंटू एच स्क्वायर इंटू 4 पाई स्क्वायर एम इंटू के जेड ई स्क्वायर. nth ऑर्बिट में कितनी टोटल एनर्जी होगी उसकी वैल्यू मिल जाएगी. डेट इज माइनस के जेड स्क्वायर ई रेज टू द पावर 4 पाई स्क्वायर एम अपॉन एन स्क्वायर एच स्क्वायर. नाउ स्टूडेंट्स, अब सिंपल हाइड्रोजन की केस में क्या होता है. लेट्स से दिस इज हाइड्रोजन in which electron is revolving around the nucleus in the ground state. When energy falls on this electron, this electron absorbs some of them energy and falls to some high energy level. But electrons are unstable there. This is because it has absorbed some energy. So it returns back to the original ground state by emitting the photon whose energy is exactly equal to the difference of this nth orbit and delta energy. This is given as initial energy minus final energy of energy level. So delta E, this is energy of photon which is emitted, whose value can be written as Hg upon lambda. And initially it was at nth energy level. So we can use the total energy expression for nth orbit. This is k z square e raised to the power 4 pi square m upon h square into n square minus k z square e raised to the power 4 pi square m upon n square h square, where this n is final and this n is initial square. So this will be k z square e raised to the power 4 pi square m upon h square into initial square plus k z e raised to the power 4 pi square m upon n final square into h square. So स्टूडेंट्स यहाँ से 1 अपॉन लैम्डा की वैल्यू लिख सकते हैं. 1 अपॉन लैम्डा की वैल्यू, दिस इज टेकिंग दिस कॉमन, माइनस के जेड स्क्वायर ई रेज टू द पावर 4 पाई स्क्वायर एम अपॉन एच सी इंटू एच स्क्वायर upon 1 upon n initial square minus 1 upon n final square. So student, this is for normal hydrogen atom, and for this hypothetical atom for positron and antiproton also, this 1 upon lambda can be written as k into z square e raised to the power 4 Hc into h square into 4 pi square m 1 upon n square minus 1 upon this is n initial square. This is lambda of that atom and this is lambda of normal hydrogen atom. So students यहाँ से हम देख सकते हैं that Z represents atomic number of that hydrogen atom. This is 1 and this Z represents atomic number of that atom. Atomic number of both the atoms as 1. So this K will be same, Z square term will be same. Now this E represents in this atom this represents charge on positron, whereas in hydrogen this E represents charge on electron. So please note that charge on positron is equal to charge on electron. So this charge expression is also equal. Here we can see this is 4 pi square. 4 is equal. Pi square will be equal. And in the case of lambda hydrogen, this m represents mass of electron, whereas this m represents mass of positron. It is also seen that mass of positron, this is equal to mass of electron. So students, this m will also be same, and Hc term, H represents Planck's constant, C represents speed of light. So these all term will also be same. We are left with this initial square minus final square difference term, and this will be also same. So we can write the ratio lambda atom. We can write 1 upon hydrogen and 1 upon lambda atom. This will become lambda of atom upon lambda of hydrogen. So lambda atom upon lambda hydrogen. This will come out to be 1. This is because when we will divide both the terms, since all are same, everything will get cancelled out. So we will left with only 1. And this matches with option first of this question, that is option A. So student, point to be understood in this question is that the lambda expression for both hydrogen in this hypothetical model came like this: kz square e raised to the power 4 pi square m hc into h square. So students, we saw that this charge on positron was equal to charge on electron. Moreover, mass of positron was equal to mass of electron. So both these expression became identical. Hence, dividing both these expression will give us the value as 1. Hence, the ratio of this lambda of hydrogen and lambda of atom came out to be 1. And option A was correct. I hope आपको ये concept समझ आया students. Thank you.